Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now we are starting with this particular video, the live session, which is on DRV. And I hope it's all good, all clear. Yes, all good. So now it's a technical thing to get started with the live session. Now there are 5 questions. Let me share the screen first. And where is the screen? So let me get started with this. So we are just sharing the screen. And DRV is the topic that we are focusing on. DRV stands for discrete random variable, also known as probability distribution. And these are 5 of my favorite questions. I consider them to be very, very nice questions. They are these 5s and the focus will be on these 5. And now these are considered something a little bit out of the box. They could fall into the category of tree diagram, permutation combination, common sense, logic, sample space diagram, and a lot of other things. So let's go to each question. Let's read it out and then attempt the question. Now, the first question that you can see on the board, that is about apples and that is about peppers. So now these are 2 separate questions. These 2, they are one question and this is another question. So we are talking about apples, we are talking about peppers. So let's go to the question. This is October-November 2014, variant 63, and this is from 2014. Now let's start with this thing. And I think you can see the screen. Yes, I can see that. So all good, all clear. And we are starting with this chapter with this particular question that says that a box contains, and let me just minimize this, a box contains 2 green apples and 2 red apples. Apples are taken from the box without one at a time, without replacement. That is the key word. When both red apples have been taken, the process stops. Now this is something new. That means the focus on taking 2 red apples. Whether you are lucky and you get 2 red apples initially, whether you get a green apple and then 2 red apples, and then different scenarios are there. The random variable x is the number of apples which have been taken when the process stops. Now they are asking for 2 parts. The 2 parts are show that probability x is equals to 3 is 1/3. Draw up a probability distribution table for x. Now those people who study with me on campus or online, they are aware of the fact that when I'm dealing with a question of DRV, so my focus is that focus on the main thing, this thing will come automatically in the sense that you have to work for it, but it will be part and parcel of that process. Now, when we are talking about x, where x is the number of apples taken, the focus is both red apples have been taken. That means if I write x is equals to 2, that means the scenario is both red apples have been taken. So therefore, probability x is equals to 2 is this thing. A total of 4 is there. It's without replacement. This decreases to 3. Now the focus is on the denominator, then focus on the numerator. Now they both are red apples. How many red apples are there altogether? That is any one of the 2, any one of the 1. Just write it. Do not be in a hurry. Do not simplify, oversimplify, nothing like that. Simply write it down. Is there any other possibility in which you can have both red apples? Of course, there are many. But this is the first one for 2. That means you're lucky the first 2 apples are red. Let me write down the possibility that what happens if x is 3, you are taking 3 turns and you are getting that 2 red apples. Now let me write some scenarios. Be very, very patient. That is one thing that you learn in statistics, to be very, very patient. I'll be writing some scenarios down which won't exist in reality, but let me write it down. I can cancel it anytime. Do not stop your thinking process. I can write 2R energy. I can write RGR, and I can write GRR. Now the focus is on 2 red apples. That means this is out of question. If you are getting 2, why should the process continue? The process will automatically stop. So therefore this one does not exist. Can this exist? Yes, it can exist. Can this exist? Yes. Now in both these scenarios, let me write it down. Probability x is equals to 3. So the denominator is what? The denominator is any one of the 4, any one of the 3, any one of the 2. That means this is without replacement, the numbers decreases. All got all clear? So now for red, let me write for R over here, that is 4. For R over here, that is 3. For G over here, sorry, that's not 4. I'm just considering the total. That's any one of the 2, any one of the 1. And for the green, I'll write a 2 over here. This is for this particular possibility. For this particular possibility, let me write it down again. That is 4, 3, and 2. Of course, I can take the first one and multiply by 2, but let me write it down. The order makes a difference. So the first one is a green, then the other 2 are red. So it's either this or this. So either this or this. So first of all, 4 into 3 is 12. This one, let me simplify it. That is 2 over 12. 4 into 3 is 12. 12 into 2 is 24. So 24 is at the bottom. 2 into 2 is 4. 2 into 2, 2 into 2 into 1. The last one is 1. I should not be making this small mistake. So that's 1. That's without replacement. That is also 4. So 4 plus 4 is 8. That is 8 over 24. Now wait a minute. They were asking this part. Show that probability x is equals to 3 is 1/3. That is, they are helping us out. So yes, answer of part 1 is probability x is equals to 3. That's right over here. That is this thing. Let me highlight it. This whole thing over here. That is 8 over 24. So that is 8 over 24, which simplifies to 1 over 3. So the first part is done and dusted when I'm looking for the second part. All good, all clear? Now, is there any other possibility? Altogether, there are 4 apples, 2 green, 2 red. So now let me focus on x is equals to 3. And again, the focus is on 2 red. Can I have the possibility of the first 2 green and the second 2 red? Yes, that is a possibility. Can I have the possibility that the first one is red, then I'm getting 2 greens and the last one is a red? Yes, that is also a possibility. Can I have this possibility of green, red, green, red? Yes, that is also a possibility. So therefore, probability of x is equals to 4, that is not 3, that is 4. That is probability x is equals to 4. First of all, let's focus on the denominator. So I'm drawing a big line, and let me draw a line with this ruler. So that's a line over here. Any one of the 4, any one of the 3, any one of the 2, any one of the 1. Now if there are 2 greens, so let me write 2 into 1. Then there are 2 reds. Let me write 2 into 1. That is the first thing. And I think the same will continue with the others. Still, if you want to write it, it's a good idea. The next one is R and R. So that is a 2, that is a 1, and then there is a 2 and the 1 in the middle. So I think that's all good. So the second one is done. R, G, G, R. This is R, this is G, this is R, and this is R. GGR. The last one, that is GRGR. So there is a green, there is a green, there is a red, there is a red, and then there are plus sign over here and then dots over here. Now all these are the same. 2 into 2 is 4, 2 into 2 is 4, 2 into 2 is 4. So I could have written it once and multiplied by 3, but I just wanted to show that the 3 different scenarios are there. So 4 plus 4 plus 4, how much is that? That is 12 divided by 24. So I think that's all done and dusted. And let me just draw a table for this. Are they asking for a table? Yes, they are. Draw up a probability distribution table for X. So this is X, this is probability X is equals to X. This could be 2, this could be 3, this could be 4. And let me just cut short the table. For 2, the answer is 2 over 12. Let me write this thing as 4 over 24. Why? I'll just let you know in a short while. That's 4 over 24. And this one is 8 over 24. This one is 12 over 24. What is the logic? The logic is just add these at a glance so that the total is 1. Yes, it's 1 because it's a discrete random variable. All the possibilities are taken. Sum of probabilities is 1. All good, all clear? So it was a little bit out of the box question. The main thing is follow the instructions and you have to do it in a particular order. So the first 2 parts are done and dusted. So this whole thing is like part 2. So this is answer of part 2, that is working for this. That was already done for part 1 also. And then working for this and then drawing up this table. So that's how these marks are obtained. So I think a lot of people are there and I think the apples are all done. And when I write this and then again apple, so I think the green and the red apple, and think that emoji was for us. So that's in the comment section. So now that is the mark scheme for this. That's how it's to be done. Now let's move to this one. Now this is like a traditional question. This is nothing special as such. Another box contains 2 yellow papers. So let me use there are orange. So let me use this orange color for this paper. And for yellow, let me use the color that is blue. So 2 yellow, of course there are no blue papers. I don't think so. 2 yellow and 5 orange. And then it says 3 papers are taken at random from the box without replacement. Now this is the traditional NCR question, which we do it using NCR. It can also be done using probability. Now it's a conditional probability question. It's not what you call a DRV question as such. Its part is DRV, part is conditional. So one thing that you should learn in probability is that don't expect that things won't merge. Permutation, combination, probability, probability distribution, conditional probability, things would get messy. So that's how things are there. So now it says, given that at least 2 of the papers taken from the box are orange, find the probability all 3 papers are orange. Now what I'll do is that I'll just draw a simple table. Let me write orange over here. Let me write yellow over here. So this is for orange. And let me use the color. So this is for orange. And this one is for, no, the other one. This is for orange. And that is the other one. Orange is O. And yellow, the blue color is there. We want altogether 3. So let me write it down. I can have 0, I can have 1, I can have 2, I can have 3. These are the different possibilities. For yellow, this could be 3, 2, 1 and 0. Now keep in mind, there are 2 yellow papers and there are 5 orange. Is it possible that you can select 3 out of 2? Of course not. But I want to write thing in a particular sequence, write and then cancel. No harm in that. So this is not applicable. So let me cancel this out. This is not applicable. This is not possible. Now let me write down the number of ways. So this is 5C1 into 2C2. This comes out to be 5. You should be very, very quick with this. NC1 is N, NC0 is 1, NCN is 1. These come in very, very handy. This is 5C2 into 2C1. That is 10 into 2, which is 20. This is 5C3 into 2C0. This comes out to be 10. The total comes out to be 35. Now it says at least 2 of the papers. This is exactly 2. This is exactly 3 orange papers. So at least 2 papers, 2 orange papers. So that is 20 plus 10, 30, which is, let me write it out, 20 plus 10 divided by 35, which is 30 over 35. No need to round it off. Now it says given. That means this is conditional probability. And when we talk about conditional probability, the condition goes down in the denominator. So let me write down the condition in the denominator, which is what? Which is 20 over 35 plus 10 over 35. This is exactly 2 orange. This is exactly 3 orange. Find the probability. All 3 papers are orange. So we are talking about these 3 oranges. They go at the top, which is 10 over 35. So this is 10 over 35 divided by 30 over 35, and this becomes 10 over 30, which comes out to be 1/3. So that is the answer, which is right over here. This is the way that I have done that alternative thing, 5C3 and all these things. That's right over here. That is the way that I have done. I'm not focusing on any other way. So let me just cancel out these ones. And this thing, the conditional, is also done. So basically, that's how this particular part is done. Let's move ahead. Now we are moving to the next question. So first question is done and dusted. I just want a little bit acknowledgement from you people that this is all good, all clear. So therefore, orange is also done. And what else was there? That is green. So orange and green papers, it's all done, all good and all clear. Let's move on to the next one. That is Judy and Steve play a game using 5 cards numbered 3, 4, 5, 8 and 9. So let me highlight these. So this is 3, 4, 5, 8 and 9. Now it says Judy chooses a card at random, looks at the number and replaces the card. Steve then chooses a card at random, looks at the number and replaces the card. So the first thing is that this is with replacement. That is one thing that you should focus on. And this is like Judy and Steve. If the 2 numbers are equal, the score is 0. Otherwise, the smaller number is subtracted from the larger number to give the score. So let me start. I have broken up the thing into 2 parts. So let me start over here. That's 3, 4, 5, 8 and 9. And this is about replacement. Replaces the card, replaces the card. If the 2 numbers are equal, the score is 0. Otherwise, the smaller is subtracted from the larger number. Show that the probability that the score is 6 is 0.08. Draw up a probability distribution table. Calculate the mean score. So let's get started by drawing a sample space diagram. So if I draw a sample space diagram, and let me draw all these lines and I'll erase the extra ones. So 1, 2, 3, 4, let me draw one more. Let me cancel it out. Okay, so let me write over here 1, sorry, it's not 1, it's 3, 4, 5, 8, 9. So this is 3, 4, 5, 8 and 9. And if the 2 numbers are equal, they are playing 5 cards. So 5 into 5, that's 25 possibilities. So this is like first pick, and 3, 4, 5, 8 and 9. This is the second pick. So now if the numbers are equal, we get a 0. So 3 and 3 is 0, 4 and 4 is 0, 5 and 5 is 0, 8 and 8 is 0, 9 and 9 is 0. Now let me write it down vertically. 3 and 4 is 1, 3, 5 is 2, 3, 8 is 5, 3, 9 is 6. Just double check my working. 4 and 3 is 1, 4 and 5 is 1, 4 and 8 is 4, 4 and 9 is 5. Let me write over here, 5 and 3 is 2, 5 and 4 is 1, 5 and 8 is 3, 5 and 9 is 4. And over here, 8, let me choose red, blue, green. Okay, let me choose this purple. 8 and 3 is 5, 8 and 4 is 4, 8 and 5 is 3, 8 and 9 is 1. Let me choose this one, 9 and 3 is 6, 9 and 4 is 5, and 9 and 5 is 4, 9 and 8 is 1, and this is a 0. Okay, so now this is all done. Now let me focus on these scores. So let me make a table. So hold for a second, let me get a color, and let me make up a table. Okay. So now let me write over here, this is X, this is probability, X is equals to X. What are the scores? 0 is there, 1 is there, 2, 3, 4, 5, 6. So this is 0, 1, please space it out, 0, 1, 2, 3, 4, 5, and 6. Now there are 25 possibilities, so this is over 25. Let me write it down. I'll work in fractions. I can later convert it into decimals. First of all, for 0, there are 5 options. For 0, this is 5 over 25. And then if I focus on 1, so this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So 1 is 6 over 25. Let me focus on 2. So that's 1, that's 2, and what else is there? There is only 2 of them. That's 2 over 25. Let me focus on 3. So do I have a 3? Yes, that's a 3. That is a 3. I think 2 over 25. And I can just double check at the end. And let me go back. That is 4. That is 1, 2, 3, 4. 4 is 4 over 25, 5. 5 is, this is 1, this is 2. I see a 5 over here, I see a 5 over here, that is 4 over 25. And 6 is this one, that's a 6, that's a 6. And do I see any other 6? No, that is 2 over 25. Now let me double check. 5 plus 6, 11, 11 plus 2, 13, 13 plus 2, 15, 4 plus 4 plus 2, 10, 15 plus 10, 25 over 25. That is the answer. That is the first thing. Now it says show that this is basically second part that I do first, the probability distribution, that is done. Show that the probability, the score of 6 is 0.08. So this is answer of part 1. Probability x is equals to 6 is 2 over 25, which is 8 over 100. And that is 0.08. Yes, the answer is correct. Calculate the mean score. So let me work out the third part. Expectation of x, that is sigma px. So therefore, this is 0 into 5, 1 into 6, 2 into 2, 3 into 2, and 4 into 4, and 5 into 4, and 6 into 2. So let me just draw a box around it so that this looks separate from the rest. Okay, so now the whole thing divided by 25. So this is 6 plus 4 plus 6 plus 16 plus 20 plus 12 divided by 25. 6 plus 4 is 10. 10 plus 20 is 30. 30 plus 6, 36. 36 plus 12 is 48. 48 plus 10 is 58. 58 plus 6 is 64. So this is 64 over 25. Let me just double check the answer. That is 64 over 25. They have written it in decimals, or 2.56. Or 2.56. This is exact. This fraction is exact. There is no rounding off. So the first three parts are done. So now what exactly is this? This is like Judy and Steve. So I'm just keeping myself ready for this. That is what we are doing. So now the real thing starts. It says if the score is 0, they play again. Okay. So probability X is 0. That is this thing, 5 over 25. Probability X is equals to 0 is 5 over 25, which can be written as 1 over 5, which can be written as 0.2. If the score is 4 or more, let me highlight this. If the score is 4 or more, Judy wins. So probability X is greater than or equal to 4, that is Judy wins. Now let me focus on what's the score of 4 or more. So that is this and this and this, which is 4 plus 4 plus 2. This is getting a little bit blurry. 4 plus 4 plus 2, that is 10. So this is 4 plus 4 plus 2 over 25, which is 10 over 25, which comes out to be 2 over 5, which comes out to be 0.4. And then it says, otherwise, Steve wins. Otherwise, Steve wins. So probability of Steve winning is basically this plus this plus this, because 0 is already taken care of. That is also 10. 6 plus 2 plus 2, that is 10 over 25. So probability Steve wins. That is also 10 over 25 or 2 over 5 or 0.4. So there are three probabilities that we are dealing with. The green probability, the red probability, and let me write over here, if the score is 0, they play again. That is this probability. So this is play again. Now it says, find the probability that Judy wins with the second choice of cards. Now, those people who are at the class, if they remember, there was one question of Eduardo. There was one question of Mario throwing that ball at a competition, the $5, the $3, the $1, the profit, the negative profit, that thing. That is basically geometric distribution, which we'll be starting on Monday. But this question was asked way before that. Officially, geometric distribution came into the syllabus in 2020. This is, I think, what? This is 2011, much before. So now they are making you think out of the box. These two parts are connected. Find the probability Judy wins with the second choice of card. Find an expression for the probability Judy wins with the nth choice of card. So I need to develop a pattern. If I'm focusing on Judy wins with first attempt, first set of cards, your choice of cards. That is just winning, that is 0.4. Now, Judy wins with second choice of cards. That means the possibility that Steve wins does not exist. Either they play again and then Judy wins. So they play again and then Judy wins. So now the pattern is 0.2 into 0.4. So this is not exactly geometric distribution. This is similar to that. Continue the pattern. Judy wins with third choice of cards. That is 0.2 into 0.2 into 0.4. Eventually, Judy has to win. Judy wins with fourth choice of cards. That is 0.2 into 0.2 into 0.2. 3 times play again and then Judy wins. Now Judy wins is red and play again is blue. So play again is like blue and then 2 blues and then 3 blues and then Judy wins at the end. Okay, now focus on this. When it's second choice, there is 1.2. When it is third choice, there are 2.2. When it's fourth choice, there are 3.2. And of course, that 0.4 has to be there. In the first choice, there is no 0.2. That means the answer for part 4 with the second choice of cards, that is this thing. So let me just highlight this. So with the second choice of cards, this is the answer right over here. So this is answer of part 4. And this pattern was developed for answer of part 5, which is what? Judy wins with the nth choice of cards. So therefore, Judy wins with nth choice of cards. So look over here. If there is 2, there is power 1. If there is 3, this 0.2 can be written as square. If it's 4, this 0.2 can be written as cube. Therefore, this 0.2 is raised to power of n minus 1. Yes, it's out of the box into 0.4. So this is the red thing and this is the blue thing raised to power of n minus 1. That is the number pattern they were trying to develop. So this was again an out of the box question. So this is about Steve and Judy. The first 3 parts were okay. The last 2 parts were kind of tricky and they were worth 5 marks. The first 3 parts, they were only worth 4 marks. So the last 2 parts were heavy duty. That's over here. This is the thing. That is 0.2 raised to power of n minus 1 into 0.4 and this is 0.4 and this is 0.2. All good, all clear? Now let's look at this one. Now we are talking about pears and oranges. So this time it's again oranges. Okay. So now it's about pears and oranges, and let me just get started with this. Okay, I just close this thing. Okay. So now it says a box contains 4 pears and 7 oranges. So let me choose the color blue for the pears and red for the oranges. 3 fruits are taken one by one. 3 fruits are taken out at random and eaten. Yeah, it's one by one and eaten. Find the probability that the first part, 2 pears and 1 oranges are eaten in any order. The third fruit eaten is an orange. The first fruit eaten was a pear, given that the third fruit eaten is an orange. So naturally, these 2 are connected, and this is conditional probability. Now over here, this thing, since we are not doing normal distribution, therefore I'm slashing it out. So basically we are working till this thing, 3 mark, 3 mark, 3 mark, that's 9 mark. And this is 2009 variant 61, and this is question number 6. So I'm just focusing over here. The pears are blue in color and this thing is oranges. I'm labeling it as red. Now 2 pears and 1 orange are eaten in any order. Now I can do 2 things. That is, either I can work it out using probability or I can work it out using combination. So if I apply method 1, that is NCR, so I'll write that without any restriction, this is 11C3. I'm not going to use the calculator. You know my way. I'll be using the calculator at the very end. I'm just getting some things ready. That is the pears and the oranges. Okay. So now this is without any restriction. And then if I am talking about 2 pears and 1 oranges, so let me write 4C2. And for the oranges, I'm writing 7C1 and I'm writing a multiplication sign. This is 2 pears and 1 orange. So basically the probability, and let me just check my phone. Okay, I think that's all good. So that is the probability is 4C2 into 7C1 divided by 11C3, and this comes out to be 42 over 165. I'll just show you the mark scheme in a short while. I would prefer method number 2 in this one, that is the concept of probability and permutation. The reason being that the next two parts is related with probability. So we are having any one of the 11, any one of the 10, any one of the 9. And we are interested in two pears and one orange. So anyone from the 4, anyone from the 3 and orange, that is from the 7. And don't forget that if you have PPO, they can be arranged in 3 different ways. PPO, POP, OPP. So therefore multiply by 3 ways of arranging it because it's permutation and probability. So when I multiply this out, this comes out to be 252 over 990. I did not reduce it. And then I reduced it 28 over 110. And this comes out to be 14 over 55. That is the answer for this particular part. All good, all clear? Now let me show you the answer. This was method number 1 using combination. And this thing is method number 2, that is using probability and permutation. This 3 was for the number of ways, the denominator, the numerator, the pear, and orange, and that's the answer. So that's how the first part is done. Now, let me do the next of the part. The third fruit is an orange, and 2 and 3, they are linked. So let me just move over to a new page so that I can work with relaxation. And now over here, I'm focusing on the same 4 pears and 7 oranges. I'm focusing on the second and the third. Now, if I'm focusing on the second part, it says the third fruit eaten is an orange. So that means it could be pear, orange. It could be orange. It could be pear, orange, pear. It could be orange, pear, orange. So now over here, let me focus on the denominator. I just need some more space so that I can work it out comfortably. The denominator is 11, 10, and 9. That is 990. That is 990. And let me write it properly. That is 990. Okay, let me check the pencil charging. I think it's all good, all clear. Now, if I'm talking about the 2 pears, so therefore, that's a blue and a blue, a blue and a blue, and orange comes at the end. I'll just fill in the numbers. And then 3 oranges over here. And then 2 pears and 1 orange in the middle. No. The third fruit eaten is an orange. So this is PPO. Let me just correct myself. The color helped me out. So this is POO. And the last one is OPO. So therefore, the orange color is there. And what is the last one? That is OPO. That is OPO. So that's a full circle. And then there is this thing at the middle. Now, when I'm talking about PPO, how many P's are there? There are 4 P's. So let me write over here. That is 4 pears. So 1, 2, 3, 4 pears and 7 oranges. 1, 2, 3, 4, 5, 6, 7. So now for PP, this is 4, this is 3 and 7 over here. That is the first one. For the 3 O's, that is any one of the 7, any one of the 6, any one of the 5. Then POO, for pears, this is 4, this is 7, this is 6. For OPO, that is, this is 7, this is 6, this is 4. Okay, so now multiply it out comfortably. And this is 84 over 990. This is 210 over 990. This is 168 over 990. This is 168 over 990. And this total comes out to be, the total probability is 630 over 990, which comes out to be 711, a beautiful number. This is the second part. Now out of this comes the third part. That is the purple thing. That is, the first fruit eaten was a pear. Given that the third fruit eaten is orange, that is this thing. So first of all, the denominator, and let me draw a line over here. So your denominator is answer of part 2. That is made up of 4 things: 84, 210, 168, 168. 84, 210, 168, 168. And of course, it's divided by 990. The numerator is the first fruit eaten was a pear. So now I am focusing on this thing. The first fruit eaten was a pear. The first fruit eaten was a pear. So these two will go up. So 84 and 168, this will go up. So this is 84 over 990 plus 168 over 990. So how much is that? Let me just add it up. So therefore this comes out to be 252 over 990 divided by 630. That is 630 over 990. This number is over here. This number is over here, 84 plus 168. And this comes out to be 252 over 630. And I think this simplifies to 0.4 exact. So let's double check. 711, that is the answer for this particular part. And this over here is 0.4, that is the answer. So that's how these two questions, these two parts are done. So how many questions have we done so far? Let's just have a look. We have done the apples and peppers. We have done Judy and Steve. We have done pears and oranges. Now we are going to these two questions. Let's move on. So we are over here. Now this question, let's go over this. It says Gohan throws a fair tetrahedral die. So now this is about Gohan. So hold for a second. Let me write over here. Where do I write? So now this is Gohan and die. Okay. Okay, G. Okay, all good, all clear. Now let's get started. So over here it says Gohan throws a fair tetrahedral die with faces numbered 1, 2, 3, and 4. If she throws an even number, then her score is the number thrown. So if she throws and she's getting an even number like 2, so score is 2. If she gets a 4, her score is 4. If she throws an odd number, then she throws again and her score is the sum of both the numbers. Okay. So now that is the thing. So die, dice, that is the thing. Okay. So now over here, let's roll on. It says let x be the random variable of the Gohan score. Show that. Again over here, show that probability x is equals to 2 is 5 over 16. Now the first thing is that, let me break this up. When we talk about even, that is either getting a 2 or a 4, the score is as it is. So even number, then her score is the number thrown. So 2, you're getting a 2, 4, you're getting a 4. So over here, I'll say probability of x is equals to 2 is 1 out of 4. Probability of x is equals to 4 is also 1 out of 4. This is for the even numbers. So x is equals to 2, x is equals to 4. So now what about the odd number? When I'm talking about the odd number, I think it's a good idea that I draw a sample space diagram. Let me just push it down and let's see which ones I'm in need of. So over here, sum. So this is about sum. This is 1, 2, 3 and 4. This is 1, 2, 3 and 4. So let me just pull this thing down over here. All good. So now we are interested in the odd number only. So yes, there are 16 possibilities, but we are interested in the odd number. So this is a 2, 3, 4, 5, 3, 4, 5 and 6, 4, 5, 6 and 7, 5, 6, 7 and 8. But I am interested in the odd number thing. So I'm interested in this one, in this line, and in this particular line. So now over here, let me focus on 2. That is one possibility. So probability x is equals to 2 is 1 out of 16. And let me focus on 3. So for 3, probability x is equals to 3 is 2 out of 16. Let me focus on 4. That is 1 and 2 from the odd. So probability x is equals to 4 based upon odd. And odd is what? 1 and 3. That is 2 out of 16. Similarly, from this, probability x is equals to 5. So probability x is equals to 5. That is 2 out of 16. And then probability x is equals to 6. That is 1 out of 16. And then I have probability x is equals to 7. That's also 1 out of 16. So let me just write it properly. This is 1 out of 16. All good? Now, are there any common ones? Yes, there are. X is equals to 2. X is equals to 2. X is equals to 4. X is equals to 4. So let me add these. The other ones will remain as it is. So probability x is equals to 2 can be 1/4 plus 1 over 16. 1/4 can be written as 4 over 16 plus 1 over 16. That comes out to be 5 over 16. So probability x is equals to 2 is this. The first part for 2 mark is done. So answer of part 1, that is done. Similarly, if I write probability x is equals to 4, that is 1 over 4. And from here, that is 2 over 16. This is 4 over 16 plus 2 over 16. This comes out to be 6 over 16, which can also be written as 3 over 8. That is already written over here. The rest of the things are already there, but I gave you the idea that if, for example, you come across a question like this, that is how you should approach. That is how the examiner filled up the table. It was very gracious of the examiner that they asked you only this part. What I have done is that solved all the parts for you. For example, for 5, 5 is 1 over 8, 1 over 8 is 2 over 16. 5 over here, 1 over 8, that's 2 over 16. 6 is 1 over 16, 7 is 1 over 16, 1 over 16, 1 over 16. Probability x is equals to 3, 2 over 16. So that thing is done. Okay, 3 is only 1. Okay, this 3 is not there. Let me correct myself. So that's a good thing. I double checked. So 3 is 1 over 60 because we are choosing out of these blue ones. So now the rest of the thing is pretty straightforward. So let me just copy this thing. And what I can do is that I can calculate expectation and variance, and it's a good thing that you're getting a practice of variance also. So this is 5, this is 3 over 8 is 6 over 16. This is 6 over 16. This is 2 over 16. Let me remove this. Let me remove this. So everything has a denominator of 16. So expectation of x, that is sigma px. That is 2 into 5, 3 into 1, 4 into 6, 5 into 2, 6 into 1, 7 into 1, the whole thing added together divided by 16. Of course, you can use a calculator and get this answer. Make a column over here for x square, which is 4, 9, 16, 25, 36, and 49. And let's calculate expectation of x square, which is sigma px square. So this is 4 into 5. This is 9 into 1. This is 16 into 6. This is 25 into 2. This is 36 into 1. This is 49 into 1. The whole thing added together divided by 16. And you will get some answer. Let me get the answers from here. This is 15 over 4. And this thing is 260 over 16. 15 over 4. And this is 260 over 16. So now the variance of x, that is expectation of x square, which is 260 over 16, minus square of expectation of x, which is what? Which is 15 over 4, the whole thing square. So this is 260 over 16 minus 225 over 16. So that is 35 over 16. That is the variance of x, that is 35 over 16. So now this question, the Gohan and the die, that is also done and dusted. Okay, so now this is all good. Let me just focus over here. Okay. Chalaji, let's move on. And now this question, just have a look. Why don't you see this particular question? It says that the coin A is weighted so that the probability of throwing a hit is 2 over 3. Now you cannot skip S1. Someone asked this thing, but this thing cannot skip S1. Chalaji. So now let's go and move ahead. So coin A is weighted so that the probability of throwing a hit is 2/3. Coin B is weighted so that the probability of throwing a hit is this much. So let me ask, focus over here. Coin A, hit is 2/3. Coin B, weighted so that the probability of throwing a hit is 1/4. That means it's not a fair coin, neither A nor B. Now the thing is, A, this is, hold for a second, coin A is thrown twice and coin B is thrown once. And then they're asking all these questions. Now before that, let me write over here. This is coin A. Since it's thrown twice, let me write it twice over here and then coin B. And then let me write head over here. That is 2/3. This is 2/3. And coin B, this is 1/4. And over here, we are writing tails. And that is 1/3. This is 1/3. This is 3/4. So that is the working that we'll be doing. So let me just increase this thing. Okay. Now it says show that the probability of obtaining exactly one head and two tails is this much. So one head and two tail. So we need this thing. Let me just highlight this thing. We need one head and two tails. Draw up the probability distribution table for the number of heads obtained, and the last part, find the expectation of the number of heads obtained. So that is easy. Now, first of all, let's work out that what if I get 3 heads? So that is the easiest thing, getting 3 heads. The next easiest thing is getting 3 tails. So let's get started. 3 heads. Probability of x is equals to 3. That is 2/3 into 2/3 into 1/4. That is this and this and this. So 3 into 3 is 9. 9 into 4 is 36. 2 into 2 is 4. So that's 4 over 36. Very simple. Probability x is equals to 0. 3 tails is 0 heads. This is 3 heads. That is this and this and this. That is 1/3, 1/3, 3/4. That comes out to be 3 over 36. These two are the easier thing. Now let's focus on this one. 1 head and 2 tails. So let me focus over here. That is 1 head and 2 tails. There are 3 options. And you are getting it. What exactly am I hinting at? So this is probability of exactly 1 tail. So now over here, head, tail, tail, and I need a page for this. So let me add a page. So over here, let me write 36 at the bottom and let me just increase it. Hold for a second. Let me just write it. Okay. So there is 36 at the bottom and there are 3 options over here. So head, tail, tail. If I choose this head, I'll multiply with this tail and this tail. So head, tail, tail, or tail, head, tail, or tail, tail, head. So these are the 3 options. So therefore head, tail, tail, that is the first one, 2/3, 1/3, 3/4. So this is 2/3, 1/3, and 3/4. And let me just remove this thing from the bottom. So this is all good. So this is the first one. This is this one. Then tail, head, tail. So this is 1/3, 2/3, 3/4. 1/3, 2/3, and 3/4. Last one, tail, tail, head. 1/3, 1/3, 1/4. 1/3, 1/3, and 1/4. So now this is 2 into 3 is 6, 2 into 3 is 6, this is 1 over 36, that comes out to be 13 over 36. Now let's make up a table because it's almost done. That is, this is x, this is corresponding probability, this is 0, this is 1, this is 2, this is 3. This is 3 heads. This is 0 head is 3 tails. 1 head is this thing, HTT. This is HTT and THT and TTH. And 2 tails, 2 heads would be HHT, HTH, THH. So this one is 3 over 36. 3 is 4 over 36. And this one is 13 over 36, and this one can be found using subtraction. So 13 plus 3, 16. 16 plus 4, 20. So therefore, this is 16 over 36. So let's double check the answer. This is 16 over 36 from subtraction. This is 4 over 36. This is 3 over 36. This is 3 over 36. Now we have to calculate the expectation. So now when we have to calculate the expected value, that is sigma px, that is 0 into 3, 1 into 13, 2 into 16, 3 into 4, the whole thing added together divided by 36. So this is 13, 32, 12 over 36, 32, 34, 44, 47, 57, that is 57 over 36. Leave the answer in the exact form. And I think that's about it. So this was the lecture on DRV, and we did some special questions over here, and the list is all over here. So stay tuned for more content on mathematics with Shahab Yaqub.